हेलो इंजीनियर्स, आई होप यू आर डूइंग वेल। होली अच्छी रही होगी और आप लोगों ने खूब इंजॉय किया होगा। सो नाउ लेट्स बैक टू द अवर वर्क। सो आई थिंक 6th of March you have a quiz, okay? And on that quiz, that one of that question have some mistake on third and fourth options, okay? So firstly we will discuss quiz part. So for that you can understand if you have any problem on there, any questions, and then we will start star to delta and delta to start and why this is required for you. Okay, so firstly start with a quiz problem. So that was your quiz. The first question is this: what is the main difference between a network and a circuit? So as we discussed, the network can be closed, can be open. If there will be a voltage source, there is no be a voltage source. Okay, network can be any circuit. Okay, that circuit must have a that voltage source or current source or closed path. Okay, so what is the main difference between a network and circuit? Network has a source, circuit does not. That first option is not correct. Circuit has at least one closed path with the source. Of course, it must have one closed path so that current can flow, and it must have a source, then only that current can flow. So this will be a B option, will be a right. See, the network has current flow. Okay, and the difference of network and circuit like this: circuit cannot contain passive element. There is not related with this difference. So that first answer will be B. Let's start with the second question. When does a network become a circuit? When does a network become a circuit? Network कब circuit बन जाएगा? When it contains a resistor, when it contains a voltage source, when a closed path exists for a current flow. Of course, you must have a closed path for a circuit, and where that current can flow, then network can convert into a circuit. So that will be a C option. Let's talk about third question. So in the third question, why are large resistor avoided in IC design? So as we discussed in analog IC design or any IC design integrated circuit, if you are designing a chip or any circuit on a chip, so you avoid the resistance. Why? Because if you design a resistance on that by the help of fabrication process, you use a poly resistor, and that will be very bulky. It will take too much space in your IC in a silica. Okay, so you can convert by the help of MOSFET. So why are large resistor avoided in IC? Because they occupy large silica area. Of course, that it will take a large space. And of course, when you talk about the IC, we will talk about the three regions: PPA, power, performance, and area. We always focus what will be the power dissipation of the circuit, what is the performance driven by the circuit, and what is area, because as per area will be high, as per cost will be high. Area is directly proportional to cost in VLSI era. So the third is the occupy large silicon area. Fourth question, which component stored energy in electric field? Of course, capacitor store energy in the form of electric field, and inductor store the energy in the form of magnetic field. So that resistor will not store the energy in the form of electric field, inductor will not, capacitor only. Okay, so this was your fourth. Okay, let's talk about fifth. Why are inductor rarely used in IC fabrication? Of course, it is too bulky, and of course it will be influence the another circuit. Okay, and it is very low in efficiency, because the frequency is very low. If the frequency is high, it will be look like an open circuit. So that they occupy large area and have low efficiency. Okay, so whenever you have an inductor, if there is a requirement of inductor, you can use op-amp, okay, to design in this way. But we are not implementing inductor such like a capacitor or like a resistor. Okay, so this was your fifth question. Let's talk about sixth. In which region does a MOSFET behave like a resistor? As we know that MOSFET have a different region. By this quiz, you can revise all the basic parts. Okay, so MOSFET have a different region like cutoff, saturation, linear, subthreshold. Okay, so in a cutoff, it is look like an open circuit, just like ID is 0. You have a saturation region, you have a linear region, you have a subthreshold. Okay, so which region MOSFET behave like a resistor? Of course, it will be a linear or triode region. Okay. What controls the resistance of MOSFET uses a resistor? Okay. So if you talk about that, MOSFET is behave like a voltage controlled resistor. So you can control the MOSFET resistance by the help of gate voltage. So this is controlled by the gate voltage. Okay, not by the drain voltage, not by the substrate voltage, not by the temperature only. You can control the MOSFET impedance or MOSFET resistance by the help of gate voltage. The eighth one, MOS capacitor. Capacitance mainly depends on what? So if you are designing a MOS capacitor, that I represent in this way, you have a gate, you have a silicon dioxide, and then after you have a body that we have a source, drain and body. So you can sort source, drain and body, and you have one terminalized gate. In between you have a dielectric, it become a capacitor. So how can you depends that MOS capacitor mainly depends on area, and the second one depends on the dielectric. Okay, the oxide thickness and area. So this was your right answer, that eighth one. Let's talk about 9th and 10th. So, oh, just a minute. Ninth, why are MOS resistor called tunable resistor? We discussed this part, that by the help of the gate voltage, you can decide how that current will be flow with the help of VGS, gate to source voltage. So why are MOS resistor called as tunable resistor? Their value, they change with the frequency? No. Their value can be controlled using gate voltage. Yes, that value will be controlled by the gate voltage. This was your right answer. An ideal voltage source has what? If you talk about the ideal voltage source have an internal impedance is 0, and that the load have a maximum voltage across that will be a voltage, that will be a source voltage. So ideal voltage source have a 0 internal impedance or 0 internal resistance. And if you talk about ideal current source, in an ideal current source you will find that infinite resistance, internal resistance. Okay, let's talk about 11th and 12th. So in real circuit, voltage drop under load occur because of, if you talk about the real circuit or practical circuit, you have a voltage source, and of course you have an internal impedance. If you have an internal resistance, it have a voltage drop. So they are just saying that in real circuit, voltage drop under load occurs because of what? Because of internal resistance of source that have a voltage drop across the internal resistance, and it have a less than the source voltage. The load voltage always be a less than the source voltage because that have a drop across the internal resistance. So that will be 11th is B. Let's talk about 12th. A dependent source is one whose output depends on a dependent source. Dependent source, we have a 4 types of dependent source, that is voltage control voltage source, voltage control current source, current control voltage source, current control current source. We have a 4 types of dependent source. If you talk about the dependent source is one whose output depends on. If you have a dependent source, it always be dependent of any voltage or any current across any branch, and branch have a impedance. Okay, so battery, capacity, and other voltage or current in the circuit, yes, that have a dependent on any other voltage or current of the circuit. किसी सर्किट की वोल्टेज और करंट पे डिपेंड करेगा डिपेंडेंट सोर्स. So this is the correct answer. A MOSFET small signal model behave like what? That if you are designing a MOSFET small signal model, we discuss in a, I think, second or third lecture, we design that voltage controlled current source. We have a VGS, you will find that GM VGS, that GM is a transconductance and GM VGS will be a total current, that voltage controlled current source. So MOSFET small signal model behave like a voltage controlled current source. A node is best defined as, okay, that was, I think that was the wrong. There will be a mistake in third and second and third question options. A node is best defined as a closed path. Always that we have a node at the point at which two or more than two elements are connected. That is the point, okay, that they are node. So a closed path, no. A single component, no. A junction where elements connect, that will be a correct answer. And I think that will be a mistake that B and C have a same option. Okay, that's why. So the answer will be a junction where element connect. A junction where elements connect. That will be your 14th answer. 15th, why are node and loop concept important in VLSI? Because once you studied about node and loop and branch, you can discuss, you can analyze KCL and KVL. So KCL and KVL, for understanding of KCL and KVL, you must have a basic understanding of nodal, branch and loop. So that's why to increase chip size, no. To apply KCL and KVL and analyze current flow, yes. Oh no, not required transistor count on to control temperature, no. So if you have a basic understanding of node, branch and loop, you can easily implement KCL and KVL. So till now, I think today we have a 7th lecture, and till now we discussed from the beginning of the network and circuit to resistor equivalent. Okay, we solve some numericals where we can analyze R equivalent. Okay, so R equivalent is okay, but whenever it will be a series or parallel, it is not correct. The circuit become complex as per you are going for a R equivalent. R equivalent is very important to convert your complex circuit in a simple circuit. So if you have a circuit and you are not getting what is happening here, you just convert and make it simple one by the help of series and parallel, or you can determine voltage and current by the help of series and parallel, as we discussed in the last class, lecture 6. Today I am going for discussing star and delta to star. Star and delta to star is one of the concept where you can make a simple circuit where you can't use the series and parallel. There will be a not use of series and parallel where we are using a star and delta. So firstly we will check that circuit, it is any problem or we are not justifying by the help of series and parallel. Then we will go for a star to delta and delta to star, so that it will be easy to solve. Okay, so today we will solve some questions on that, but firstly we will understand how you convert star to delta and delta to star and how it will be look like. So let's start star and delta to star. And if you have any question on the quiz was very simple. The first quiz design, okay, the quiz is very simple. As per that we are going for assignment. In the assignment you will solve some questions, and the questions in answer will be in multiple choice question. You solve that questions and find that what will be the option and solve that, so that you can be better on network. If you are good in network, I am really sure about that you will be good in analog circuit design, because this is the funda. This is the foundation of everything in a back-end design. Without that, you can't understand how current is flowing, what is the voltage across that branch. So that is very important. And I am just taking a very simple topic, that resistor capacitor. Once we are entering a EDC where we are introduced diode, MOSFET, then the circuit become more complex. You can think in this way, this is a simple circuit by the help of resistor. Just convert this resistor with the help of MOSFET, the circuit become complex. So firstly, understand the fundamental, then you can explore your understanding. Okay, so let's start with the star to delta and delta to star first. So this is look like a star. So if you have a like this, or you can say that this is look like a T, okay, in a rotated version of that. So if you have a look like this circuit, whenever you have a circuit, if it is present like this way, okay, we will solve that questions on that. You have a 3 terminal and they are connected in this way, so you can convert into a delta. Delta is what? Basically this is a star, you can convert into this format. This is called delta. I am just converting star to delta. So I can avoid this star and just convert into a delta form, that is ZA, ZB and ZC. What will be the value? We will discuss, but firstly convert into that format. Okay, let's, you have this type of circuit, or I can say that okay, you have this type of circuit. This is T form. If it is looking like this, you can convert into a delta. You can like this, like this, like this. Okay, whenever you have this type of circuit, and this is not will be easy to solve. Okay, we will solve that question where you will find that there is no series, there is no parallel. So where we can convert into a star to delta or T to pi. And what will be the value we will discuss. But firstly try to understand how we can convert it. So if this is Z1, Z2, Z3, it will be ZA, ZB, ZC. What will be the value of ZA, ZB, ZC? We will discuss. So if you have a star formation, the value of ZA, ZB, ZC is what? The ZA will be, what is the value of ZA? It is conversion of star to delta. So delta will be a formation of, ZA is formation with the help of Z1 and Z2, because this is a adjacent. ZA is a adjacent of Z1 and Z2. So sum of adjacent, the sum of adjacent means Z1 plus Z2 plus product of adjacent means Z1 into Z2 upon remaining, that is remaining is Z3. This is the formula. Let's talk about ZB. If I am talking about ZB, what is the value of ZB? The ZB is formation with the help of Z1 and Z3. So sum of adjacent, Z1 plus Z3 plus product of adjacent, that is Z1 into Z3 upon remaining, that is Z2. Okay, let's talk about ZC. How we can convert ZC in the form of Z2, Z3, Z1, Z2, Z3. I am just telling that you know Z1, Z2, Z3 value. I am just converting this value into a ZA, ZB, ZC. So how can we? That ZA will be a adjacent, that value is adjacent by Z1 and Z2. So Z1 plus Z2 plus Z1, Z2 upon Z3. If I am talking about ZC, ZC will be the adjacent of Z2 and Z3. So ZC is what? Z2 plus Z3 plus Z2 into Z3 upon Z1. So whenever you have a star form and you are converting into delta, so that is the formula, the sum of adjacent plus product of adjacent upon remaining. Sum of adjacent plus product of adjacent upon remaining. Okay, Let Z1, Z2, Z3 are same. That value is Z, Z, Z. If Z1, Z2, Z3 is same, let this is 3 ohm, 3 ohm, 3 ohm. What is the value of ZA, ZB and ZC? So if all impedance of a star is same, so you can think in this way, if Z, 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 so Z into Z plus Z plus Z plus Z into Z upon Z will be a Z plus Z plus Z, that will be a 3Z. So I am telling that if Z1 is equal to Z2 is equal to Z3 is equal to Z, so ZA is equal to or ZB is equal to or ZC is equal to 3Z. Just check it. This is 3 ohm, 3 ohm, 3 ohm. The value will be 3 plus 3 plus 3, 3 into 3, that is 9 upon 3. 3 plus 3 plus 3, that is 3 3 is 9. That value is 5. Let that Z1, Z2, Z3 is 5. So 5 plus 5 plus 5 into 5 is 25 upon 5, that will be 5. 5 plus 5 plus that is a 15. That is a 3 times of Z1, Z2, Z3 if Z1, Z2, Z3 is same. So the question will be in this way, okay, that you have a question where that you have a star formation, you are just find that okay, what will be the delta form. So you are just convert star into delta, and if all the impedance of the star is same, the delta will be directly is 3 times of star value. So if Z1, Z2, Z3 is same, so ZA, ZB, ZC will be a 3 times of that impedance. So this is the way. So if Z1, Z2, Z3 is same, that ZA, ZB, ZC will be a 3 times of that, and that is possible only in star to delta. So that very basic formula of that star to delta is what? So if we are converting star to delta, that sum of adjacent impedance plus their product upon remaining impedance. Sum of adjacent impedance plus their product upon remaining impedance. That is that very basic formula. And that is very important when you solve that R equivalent based question. Okay, let's talk about delta to star. So if you have a question where you are trying to determine value for delta to star. So I am just saying that okay, you have this type of circuit and you are trying to convert into a star formation. So if you want that conversion in this form, in previously you convert star to delta, now I am converting into delta to star. And I am saying that the delta value is ZA, ZB, ZC and star value is Z1, Z2, Z3. This is Z1, this is Z2 and this will be a Z3. So firstly understand how we can convert it. This is a delta form. I am just converting into a star like this. Or I can say that okay, you have a pi form like this. You can convert into a star. Like this. It is ZA, ZB, ZC, it will be Z1, Z2, Z3. So firstly understand, if you have this type of circuit, if you have a previous one that is a delta type, you can convert into a star. And what will be the value? Let's figure out what will be the value. So if you talk about what will be the value of Z1, Z2, Z3, so if you are converting delta to star, Z1 will be the form of with the help of ZA and ZB. Z1 will be the form of ZA into ZB, that is a product of adjacent upon all, sum of all impedance, that is ZA into ZB upon ZA plus ZB plus ZC. If you talk about Z2 is the formation of with the help of ZA and ZC. So what will be the value of Z2? ZA into ZC upon total impedance, that is ZA plus ZB plus ZC, that is your Z2. That is ZA into ZC upon ZA plus ZB plus ZC. Product of adjacent upon sum of all impedance. If you talk about ZC, ZC is the Z3. So if the Z3 is what? The formation with the help of ZB and ZC, because the adjacent value is ZB and ZC. So Z3 will be ZB into ZC upon ZA plus ZB plus ZC. So this is very basic formula where you can use to simplify your circuit, and by the simplification of this circuit you can solve that complex R equivalent based question. You will face these type of question in gate question if you are interested on gate. Okay, so in terms of gate you will find that star to delta and delta to star formation based question. Okay, so one of that question we can solve it also, otherwise I will give that in an assignment. Okay, so firstly what I am just doing, I am just taking that ki in the circuit where is delta. If you have a delta, I can convert into a star, or you have a star, you can convert into delta. So that will be easy to solve. Okay, so that is the way that what is happening, that Z1, Z2, Z3 you can form by the help of ZA, ZB and ZC. You know the value of ZA and ZB, ZC, you can determine what is Z1, what is Z2, what is Z3. And what is that formula? That Z1 is the ZA into ZB upon total impedance. Product of adjacent upon total impedance. Similarly, if all the impedance of ZA, ZB, ZC is same, if ZA is equal to ZB is equal to ZC, if ZA is equal to ZB is equal to ZC is equal to Z, so your Z1 or Z2 or Z3 will be what? Z into Z upon Z plus Z plus Z, that is Z by 3. So whenever you have a delta, you are converting into star, and if the value of delta is same, let this is 3 ohm, 3 ohm, 3 ohm, so this will be a 1 ohm. Why? Because it will be Z by 3. So I am just writing in a one line. So Z1 or Z2 or Z3 will be Z by 3. How? Z into Z, that is Z square, upon Z plus Z plus Z, that is Z square upon 3Z. Z is cancelled out, that is Z by 3. So when you talk about star to delta, when you are converting star to delta and all the impedance are same, that will be a 3 times of that impedance. If Z1, Z2, Z3 is 3, Z1, Z2, Z3 is Z, so delta value ZA, ZB, ZC will be 3 times of that Z. If you are converting delta to star and ZA, ZB, ZC is Z, so star value that Z1, Z2, Z3 will be a Z by 3. So this is the way you can solve it. Okay, so here you have a ZA, ZB and ZC, that is converging into a Z1, Z2 and Z3. And what is the basic formula? The product of adjacent impedance upon total impedance. That is the formula of that delta to star. So we discuss star to delta and delta to star. In star to delta, sum of adjacent plus product of adjacent upon remaining. If you are converting delta to star, product of adjacent upon sum of all impedance. That is that value. Okay, let's solve that and let's try to solve this question. So okay, we have one question where we have a to B. We are trying to determine what is the R equivalent across AB. We have the value of 3 ohm, 3 ohm, 3 ohm, 3 ohm. So just I am putting this way, okay, this is A, this is B, let's say that this is C, and of course this is not short with anyone, so this will be a D. And whenever you have a ABCD formula, always try to make a weight stone bridge. So that will be easy to analyze the circuit. So you have a ABCD, I am just designing in the terms of A, B, C and D. And I am just connecting in this way, okay, A to B, we don't have any value, we are trying to determine A to B, where A to C is 3 ohm, so A to C you have a 3 ohm. A to D you have a 3 ohm. Everywhere you have a impedance is 3 ohm. B to D you have a 3 ohm. I am writing B to D you have a 3 ohm. And B to C you have a 3 ohm. That is B to C you have a 3 ohm. And you have a C to D you have a 3 ohm. That is the value. Okay, so this is the way, and you are trying to determine what is RAB. So if you know the balanced Wheatstone bridge, you can solve in a one line. What is the value of, what is the meaning of balanced Wheatstone bridge? In a ninth class, you use a potential divider and you have a one tray and you are just smoothing one wall and you find that what will be a value by the help of galvanometer. What we are doing in that class, we use that one meter, that is galvanometer, and we are adjusting any value in terms of AB or AC or any value. Let I have a AC and we don't know what is the value of AC. I am just taking that value in this way. If the current is 0 through this branch, so I can say that this bridge is balanced. Or I can say that if you have a value that AC into BD, the value of AC, a value of BD, let this is P, this is Q, this is R, this is S. I am just saying that in between AC you have a P value, in between BC you have a Q value, in between AD you have a R value, in between BD you have a S value. If that cross sectional, that is P into S, is equal to Q into R, the value of that impedance into value of that impedance multiply with equal to the value of that impedance into multiply of that impedance. If they are same, so current is 0. And if there is no current, so that means there is no any resistance. If the current is 0, that means it is an open branch. And this is open, so you can simply solve it in between A to B. So there is no impedance. If there is no impedance, so I can say that okay, if there is no impedance, the circuit will be like this, and this will be 3 plus 3 is 6 ohm, and 3 plus 3 is 6 ohm. 6 and 6 are in parallel to become a 3 ohm. So it will be in a one line. You can solve it, okay, by the help of Wheatstone bridge. But I'm not sure that you know about the Wheatstone bridge. If you know star to delta and delta to star, you can use that method and can solve it. Okay, so I am not going to solve with the help of Wheatstone bridge. I will solve with the help of star to delta and delta to star method. Okay, so if you know star to delta to star, star to delta, that will be very easy to solve that question. Otherwise, you know that potential divider, or if you know that Wheatstone bridge, you can solve in that way. So let's solve this question by the help of star to delta and delta to star. So if you are looking from this circuit, this is what? This is looking like a delta now. Yes, please. Or you are looking like this circuit. Of course, why I am going for star to delta and delta to star? Because this 3 ohm have a problem. By this 3 ohm, this is a connection in between C to D. We cannot say that this 3 ohm will be a parallel of this. We cannot say this 3 ohm will be a parallel of this. By this 3 ohm, we are stuck in here. We are not defining which one is series and which one is parallel. If there is no impedance, you can simply say this 3 ohm in series, this 3 ohm in series. But if you have this impedance, it become a problem for you to determine which one is series and which one is parallel. So I am just saying that okay, you have this circuit. If I will eliminate this resistance, if I am eliminate this CD impedance, we can solve easily. How we can avoid this impedance? So I am just looking this circuit. I am just saying that okay, it is look like a delta there. It is looking like a delta. Or On the right side, it is looking like a delta. Any one of that you are converting delta to star, it will be easy. How? Just I am converting that, okay, this is delta, and if you have a delta like this, sorry, if you have a delta like this, how you can convert into star? Just you convert in this way, okay, that this way, or this way. This is star. Delta to star. Just convert into a that way. You can find it. Okay, this is the method. You have a delta that will be like this. You just convert into a star. I am just using this method to convert delta to star. By the conversion, okay, this is delta. I can convert into star form like this, like this, like this. And if you convert into delta to star, what will be the value? The value is 3 ohm, 3 ohm, 3 ohm. Delta have a equal impedance, the star will be Z by 3. So this will be a 1 ohm, 1 ohm, 1 ohm. Why? Or you can solve it. 3 into 3 upon 3 plus 3 plus 3. 3 into 3 upon 3 plus 3 plus 3, because delta to star. So this is become a 9 upon 9, that is 1 ohm. Or I can say that Z by 3. So if you are converting delta to star, this circuit will remove. This will be a remove. Or this will be a remove. And the value is 1 ohm, 1 ohm and 1 ohm. I am just converting delta to star, the value is like this. Now the circuit will be like this. Now I can say that the circuit is like this. This is 1 ohm, this is 1 ohm, this is 1 ohm. This is 3 ohm, this is 3 ohm, and you are talking about AB. Okay, just check it. This is correct or not? This is 1 ohm, this is 1 ohm, this is 1 ohm, this is 3 ohm, this is 3 ohm. Just I convert this. If you are looking from this branch, this 1 ohm and 3 ohm are in series. This 1 ohm and this 3 ohm are in series. So the circuit is like this. This is 1 ohm. This is 1 ohm. This 1 ohm and 3 ohm are in series, so it become a 4 ohm. This 1 ohm and 3 ohm are in series, it become a 4 ohm. 4 ohm and 4 ohm are in parallel. If equal impedance are in parallel, how many times they are in parallel? That will be a divide by. They are in parallel in 2 times, that is 4 by 2. Or you can write it 4 into 4 upon 4 plus 4. Or you can write it 1 by 4 plus 1 by 4. It will be 2. So that value, if you solve this, so this is 1 ohm and this is 2 ohm. That value across AB is RAB is 3 ohm there. So this is the way you can solve that question. This is the formation of star to delta or delta to star. By the help of delta to star, you can solve this. Or by the valence bridge also, that the value is 3 ohm. So if you are using by the help of balance bridge or you are solving by the any method, the answer is 3 ohm only. But which one is better, where you are is confident to solve that question, that will be a major part for you. So just revise this question. I am saying that you have one question where I have a AB. You are trying to determine what is RAB. So I just use a node here, that is C and D. Of course, there is no common, so that's why every node is different. So this is A, B, C, D. So I have designed by the help of A, B, C, D. Whenever you have a 4 node, always try with a Wheatstone bridge. So I designed with the help of Wheatstone bridge that you have a 4 node A, B, C, D. and we find it, okay, this is a problem. In between CD you have an impedance. If you have a CD have an impedance, we can't decide which one is series and which one is parallel. So there is one method to use a star, that is a balance bridge, or otherwise you can use a star to delta or delta to star. So always try star to delta and delta to star, that will be easy for you. So by the help of star to delta, you just convert into a 1 ohm, 1 ohm, 1, that is delta to star, that is, this is 3 ohm, this is 3 ohm, this is just converting into a star. So this is Z by 3, Z by 3, Z by 3, that is 1 ohm, 1 ohm, 1 ohm, and just eliminate this delta part. So this 1 ohm, this 3 ohm, if you are looking this part, this is in series and this is in series. 1 ohm and 3 ohm are in series, 1 ohm and 3 ohm are in series, that will be a 4 ohm, and they are 4 ohm, so that 4 ohm 4 are parallel, so it become a 2 ohm, 1 ohm plus 2 ohm, it will be a 3 ohm. So this is one type. That there is not necessary to make that delta to star only left part. There is not necessary, you just convert into a right part. You can solve this question, just convert into a right part and solve that part, you will find it. The answer will be 3 ohm only there. Okay. Okay, let's solve this question. And these are the variety of question. If you are good in this type of question, that means you are good in R equivalent. You have an understanding how can you solve that R equivalent based question. Because these question will help you how you can solve, how can you make that in a simple circuit. This is a complex circuit. Why? Let's talk about it. This is A, so this is also A, this is also A. These are the A. This is B, this is B, this is B. We don't know what is that. This is C and this is D. So in between A, B, C, D, you have a node. You have a 4 node, you just convert into a Wheatstone bridge. Let's try. We are not using a Wheatstone bridge here. Just try to solve that question by looking that circuit. So you have a ABCD. By this value, by this 10 ohm, if this 10 ohm is not present, so these in series, this in will be a series. Let's try this is not present. So this is 10 ohm, 10 ohm are in series, 20 ohm, 20 ohm are in series. This 20 and this 40 will be in parallel and 30 will be in parallel, and that is a one line answer. That is 10, 30 ohm, 20 ohm, 40 ohm are in parallel, that will be a solve. But if you have this impedance 10 ohm, that will be a problem. You can't understand which one is series, which one is parallel. Why? Because by this 10 ohm, you can't say that this 10 ohm and 20 ohm are in parallel. One node is 6, but another node is not 6. For a parallel, you must have two node must be parallel to each other. Two node must be present, and in between the two node, you have more than two elements are present. You have A, but there is no B or D. If this is D, then only I can say that this 10 and 20 are in parallel. So that is the problem. Similarly, in a bottom side, you have a B, you have a point. That one node is present, but in a second that node, this C and D have a different node. So this 10 ohm, this 20 ohm are in not parallel. So in between CD, you have ambiguity to determine is where is parallel and where it is series. So how can you solve that question? You just think in this way, okay, there is no any determination in between AB, this is 30 ohm is correct, but in between this, we can determine is series and parallel. So how can we eliminate this 10 ohm? If we can eliminate this 10 ohm, we can solve it. So just think in this way. Okay, we have a circuit. If you are looking this part, this 10 ohm, this 10 ohm, this 10 ohm, this is look like a star, na? Or this is look like a T. This is look like a T. If you want to convert into a star, it will be like this. It will be like this. It will be like this. That is the delta. That is a conversion of star to delta. So I am just saying that okay, this will be a impedance, this will be a impedance, and this will be a impedance. And what will be the value? If all the impedance are same in a star, you can convert into a delta, and that delta will be at 3 times star to delta. What is that value? What is the value? 10 plus 10 plus 10 into 10 upon remaining, that is 10. That is 3 times of that. If all the impedance are same, just think in this way, if all the impedance are same and then you are converting star to delta, it will be a 3 times. So this is what? This is 30, this is 30, and this is also 30. If you are not getting this point, let that value is Z1, let this is Z2, and let Z3 Z3. And if all these values are 10, 10, 10, this is 10 ohm, this is 10 ohm, this is 10 ohm. So what will be the value? So if you are converting by this, that like this is Z1. So Z1 is what? By the help of 10 or 10, it will be 10 into 10 plus 10 plus 10 into 10 upon remaining, that is 10. That is cancelled out, that will be a 30. So this is 30, this is 30, this is 30. Okay. So if you convert delta to star, you can avoid this impedance. You can avoid this impedance. You can avoid this impedance. Okay. And now the circuit will be like this. Okay. Just check it. It is correct. So I am just converting that star to delta, and that 10 ohm, 10 ohm and 10 ohm R will be cancelled out and will be a value of 30, 30, 30. Now it will be what? I am just looking by this A to B, you have a 30 ohm, 30 ohm are in parallel. In between A to D, you have 30 ohm and 20 ohm are in parallel. In between 30 ohm and 20 ohm are in parallel. So circuit will be easy. So you just convert into that form, that is, you have a 30 ohm, and by the star to delta it will be a 30 ohm, you have a this value, that is 20 ohm and 20 ohm, and here you have a value. I just say that okay, this value will be a 30 ohm and 30 ohm. Just check it, it is correct or not. This 30 ohm, 20 ohm are in parallel. This 30 ohm, this 20 ohm are parallel, and this is the point of D. This is also D. Yes. So this is 30 ohm, 30 ohm are parallel. This is 30 and 20 ohm. This is 30 and 20 ohm. Whenever you have a 30 ohm, 20 ohm are in parallel, what will be the value? This is 30. This is 30. And 30 and 20 are in parallel. 30 and 20 are in parallel. Whenever 30 and 20 are in parallel, that is 1 upon 30 plus 1 upon 20. So this will be a what? Any value you can take it. That is 600 or 60. That is 2. That is 3. 1 by R. R is equal to 60 upon 5. That is 12 ohm. Yes. The value is 12 ohm. So this is 12 ohm. This is also 12 ohm. This is 30 and this is 30. Just check it. Now this 30 ohm, this 30 ohm, and this is 24. So the value of RAB is what? So 1 upon RAB is 1 upon 30 plus 1 upon 30 plus 1 upon 24. Just solve this. and that will be your value. This is your part. This is not my part. Solution is your part. Okay. Okay. So this is the way. You can take the LCM is 120. So this is 4, and this will be a 5. Okay, that will be a 8, and 8 plus 5 is 13. So this is 120 by 13. Just check it. Okay, so that LCM is 120. Okay, so this is 4, this is 4, and this will be 5. That RAB is equal to 120 by 8 plus 5, that is 13. 120 by 13. Just check it. Okay. So this is the way you can solve it. Okay. So these are the solutions. Just follow that part. So you can easily solve that R equivalent based question. Okay, I have one question for you. Just solve it. Okay, take your time. Take your time. You have a, okay, take a 5 minute. Okay, we have a 5 minute or 10 minute. Just solve these questions. I am waiting for your answer. Okay, just solve that question. Ki what is the value of RAB for this type? Okay, yes, please. Dear VXJPI, we are not going for the proving. Okay, this is not just like a proving method. Okay, we are not going for a proving. I am just explaining that how to use this star to delta and delta to star. I am not going for any proving. Okay, if you want, I will share some notes to prove it, because once we go for that proving night, this class will be too much bulky, and you will bore off also. Okay, so I am just using that method. We have some understanding, we have some knowledge of that star to delta and delta to star, and just implement that. The problem is that the answer will be what, that how you can implement, not like this ki how you can prove that value. No one can ask how you can prove this, but everyone want ki how you can find that ki where you can use a star to delta and delta to star to make this simple circuit. If you have this type of question, how can you? Okay, so please go with that implementation. Okay, engineer always try to implement that part. Okay. Okay, just solve that question there. You have one question, just solve it. I am waiting for you. Solve that question. Yes, everyone. Yes, Lord, Ramtesh, VX. Yes, yes, anyone. Please take your time and solve it. What is the value of RAB? Uh, I think you got that point here. That Lord, कि every time wheat stone bridge is not uh, easy for you to solve that circuit. Okay, you must require, there is not every time that PS is equal to RQ. Okay, so when you will find that bridge is not balanced, then you require a star to delta and delta to star. So that's why always solve with the help of star to delta and delta to star. Okay, that Lord is saying that 10 ohm. Okay, I don't know what is the answer there. Just I have a question for you. Yes, everyone, please take your time and solve this type of questions. Don't solve with a very easy questions. Okay, solve these type of question also, so that it will be boost your knowledge or your uh, understanding about R equivalent. Okay, and I will give some questions also on that, so that will be easy for you. Okay, it may be assignment, but it will be helpful for you. You can collect that question and solve this part. So once you go for any company interview, like you will go for ST or you will go for uh, TI, you will face these type of question. Basically, they want to solve these type of question to understand you have a knowledge about this or not. If you have a current mirror circuit, or you have a sample and hold circuit, or if you have a LDO, or if you have a BGR, and they are trying to determine what is the output impedance and input impedance, you must have an analogy of star to delta and delta to star. So you can easily understand what is the output value of the impedance, what is the input impedance, and why they are necessary, because they are directly affect your loading. As we discussed in the last class in the terms of inverter, as per the input impedance is infinite of the MOSFET, so that there is no any loading effect, means there is no any effect by the help of any resistor. Why? Because the input impedance is infinite, that means current is zero, there is no any voltage drop, so that the output of any circuit will be same for a input of the MOSFET. So that's why it is required for you. Or we analyze one circuit, that is op amp. In a op amp, we say that, yeah, input impedance is infinite and output impedance is zero as per ideal op amp. So in an ideal op amp, we read about that ideal characteristic of the op amp. We say that input impedance is infinite and output impedance is zero. Why? Because if the input impedance is infinite, that means you have an input, that input will be a main input for your circuit. There is no any internal resistance drop. And the second point, if that you have a output impedance is zero, so that it have a dependent voltage source, and the output impedance is zero, so that will be same your output, main output voltage. So ideally we want that output impedance is zero and input impedance is infinite, but practically it is not. So that's why these analogy is very important. Okay. Okay, solve these question. Okay. I will give some questions on assignment also. Okay. Sir will say that some questions. It may be assignment, it may be a mock. Okay. So analyze these star to delta and delta to star, so that you can understand these questions and solve it. Okay. And Lord say that this is 10 ohm. I don't know. We will solve it. I'm just give the hint ki how you can solve it. I'm not going for the solution. If you are looking this circuit, this 30 ohm and this 30 ohm are in series there. In a one line, you can say that this 30 ohm, this 30 ohm are in series. So this 30 and this 30 become a series and it become a 60 ohm. If this is become a 60 ohm, this 60 and this 30 will in parallel. If you are not getting this point, you just say that, okay, this is A, this is B. I'm saying that this is C, this is D, this is E. Okay. So if you are looking this D to E, you have a this 30 ohm, this 30 ohm are in series. It become a 60 ohm there. And D to E, you have 30 ohm, D to E have a 60 ohm. 60 ohm or 30 ohm are in parallel. That will be a 20 ohm. If you are looking 30 and 60, so 30 into 60 upon 90, it will be a 20 ohm. So this is 20 ohm. In between D, you have a 20 ohm. Okay. And this D is 20 ohm. This is 30 ohm. This is 30 ohm. This is 30 ohm. You can convert in this delta to star there. This is delta. This you can convert into a star. That 30 and 30 it become 10 ohm. This is 10 ohm. This is 10 ohm. This is 10 ohm. You just convert into a this. This is 10 ohm. This is 10 ohm. This is 10 ohm. So this circuit, this circuit, this circuit will eliminate. You can eliminate this one. You can eliminate this one. Okay, this is the way you can make a simple circuit. Okay. So this is 10 ohm. This is 10 ohm. This is 10 ohm. Okay. And now this will be what, that the value is here, that what is happening, this is 30, this 60 and this 30 become 20, so this will be a 20. If you are looking this part, so you can eliminate this value, you can eliminate this value, you can eliminate this value and become 20 ohm there. Okay, this 20 ohm and this 10 ohm are in series there. So this 20 ohm and 10 ohm it become a series. This is 30 ohm there. So this is 30 ohm, this is 10 ohm, this is 30 ohm. You can represent in this way. Okay, so this is the circuit that you can, this is not 20 ohm, it becomes 30 ohm there. So this is 10 ohm, this is 30 ohm, this is 30 ohm. You can convert into a star. This is delta, basically this is delta. You can convert into a star. If you are converting this into a star, it will be like this, it will be like this, it will be like this. If you convert in this way, 10 ohm, 30 ohm, 30 ohm are in series, that in delta to star. So this and this are in series, this and this are in series, they are in parallel. This is like this. Okay, this is the way you can. Okay, so you will try. I am not going for the solution, I am giving just idea. It may be a different, you can solve by the upper side. You can think, okay, by the help of the second upper one you can solve it. It's up to you there. I am just telling that please solve these type of questions. Okay, and we will solve that in the next class. But firstly, solve at your end, because practice is your only. Okay, just solve these type of question, and I will give some, I think 5 to 10 questions on that. So you can practice on star to delta and delta to star. So you will be in good analogy part. Okay, we can solve any type of star to delta and delta to star based question. And we have some gate based question also. So I will give some questions on gate based. Okay, so I think it is enough for star to delta and delta to star. If you have an idea, just implement on the circuit. That is the part of that star to delta and delta to star. Okay, so in the next class we will start from that, and we will start some more question on this, and then we will start our Telegrams theorem, where we can analyze the power. Okay, the amount of power it delivered is equal to the power absorbed. Okay, so we will discuss about the active element and passive element, and then we discuss nodal and mesh. So firstly solve these type of question, and then we go for the Telegrams. So I hope you will solve this type of question, and we will discuss in our next class. Thank you so much, dear.